All right, so when you don't know what the graph of a function looks like, one really good thing to do is to make a table of values so that, oops, so that you can see what your graph looks like. So if my graph is f of x equals the square root of x, then some of these numbers we know the square root of, right? We know the square root of 9 is 3. We know the square root of 4 is 2. And the square root of 1 is 1. And the square root of 0 is 0. What about the square root of -1? We know the square root of -1, right? What is it? Is it real or imaginary?
Imaginary.
It's imaginary. What imaginary number is the square root of -1? I. Good. So the square root of -1 is I. However, we can't graph I on the real plane. So because we're only talking about real numbers, we're going to write undefined. U-N-D, short for undefined. Okay? So we're not going to graph a point at -1 because we don't have I on our coordinate plane. We can graph 0, 0, 1, 1, 4, 2, and I think 9 will fit. Let's see, 1, 2, 3, 4. Yeah, 9 3s over here. And this one here on the left, this is an end point because everything to the left of this is undefined. You can't do the square root of a negative number and get a real number, only imaginary. But on the right side, it keeps going. Let's see if one of these pens wants to work for me. All right, what questions do you have so far about our graph? All right, I see some people with computers open. I'm going to ask you to close your computer so that you can focus on this. It's been a long time since we've talked about domain and range and increasing and decreasing intervals, and I'm going to be doing a little bit for you here, but pretty soon when we get to the practice problems, you guys are going to be doing it, so you need to actually be processing this. All right. Our domain starts at the first number I can do the square root of, which is 0. And it includes 0, so I use that square bracket. And then it keeps going all the way to the right, so it keeps going to positive infinity. Remember that domain is your x values. Range is your y values, so your y values also start at 0. That's the first y value that's defined. And then it keeps going up. So this arrow here is going right, but it's also going up. So your range is also 0 to infinity. So remember that the square bracket means including 0. Your x-intercept and your y-intercept, these are points. So points are always going to be written with parentheses. And this graph happens to cross the x-axis and the y-axis at the same point, which is the origin at 0, 0. Is this square root function increasing or decreasing as you read it from the left to the right? I heard a couple votes for increasing. You guys agree? Increasing as you read it from left to right. So I'm going to circle increasing, and then we're going to write the interval it's increasing over. It's going to be an interval of x values, and you always use parentheses for increasing and decreasing intervals. So it starts increasing here on the left at x is 0, and it keeps increasing until x is infinity. So you'll notice it looks a lot like the domain because it's increasing for its entire domain. However, it doesn't have a square bracket. Increasing and decreasing intervals only have parentheses. All right, end behavior. It's going to have as x goes to, and then we'll do y goes to, and then as x goes to. So on the right side, x is going to positive infinity. As x goes to infinity, the y is going up. So it's going to infinity. On the left side, x is not going to infinity. It stops right there. So x can only go to 0. As x goes to 0, y is also going to go to 0. So that's new because we have a stop point right there. A square root function has an endpoint. A cube root function is going to have something called an inflection point. So I'm going to circle endpoint. And my endpoint is right here at 0, 0. All right. I'm going to give you a minute. I want you to do cube root. Remember that you can find cube root on your calculator if you're not sure what the cube root of a number is. And that is in the math. So if you press math on your calculator, you should be able to get a cube root. And you can do the cube root of these numbers, fill this in, and then try to make your graph, and then fill in this part right here, okay? I'm going to check in on some of you guys because I think some of you are still missing some things for me. All right, so I saw a lot of you use the math button, and you did the cube root of these numbers, and we get -2, -1, 0, 1, and 2. Does anybody need help finding that on the calculator? Okay, so we can do the cube root of a negative number. We can't do the square root of a negative number unless we're dealing with imaginaries. So here's my 0, 0 in the middle, -1, -1, and then -8, -2. And then over here, 1, 1. Oh, yeah, sorry. So that was 0, 0, -1, -1, and -8, -2. Then over here is 1, 1, and 8, 2. And so this one makes kind of like a flatter rainbow than the rainbow we got out of the square root function. And then this one's upside down. Okay. And it's kind of hard to draw exactly what's going on, but this side is going to keep going up. Just starts going up more and more slowly. This side is going to keep going down. It just keeps going down more and more slowly. So it doesn't change direction like a roller coaster or anything like that. All right. So now that we have the graph, I'll look for anything that's different, and then the rest of it I'm going to have you guys fill in. So domain and range you should be able to do. X and Y intercept you should be able to do. Even increasing, decreasing, and end behavior. This one has not an endpoint, but something called an inflection point. So an inflection point is where your graph changes its concavity. This is called concave up on this side because if it were like a cup, you know, it would be facing up. And then this side is called concave down because if it were a cup, it would be like facing down. So it changes its concavity at the inflection point right there. And we just name it, which is right here, 0, 0. Okay, let me give you another minute to see if you can fill in some of these things. If you're like stuck on domain and range, go to x-intercept, y-intercept, and then we'll go over them. If you're done and you feel good, you can be moving ahead. Okay, let's see how you did. All right, your domain is your x numbers. It's going to start here on the left, and this one is going all the way to what? This arrow. Negative infinity. So my domain is negative infinity until what? Positive infinity. For some of you, it's coming back. It's been a while since we've done this, right? Am I frozen? No, I'm not. Okay. All right, your range. Your range is trickier because it kind of looks like it levels off, but it doesn't. This one is still going downwards to negative infinity. And then this one is going up to positive infinity. And it's tricky to see that on your cube root function, but it's true. All right, this function also looks like right now it's having the same x and y intercept. That won't be the case when we start transforming it around, but this one is. The x-intercept and the y-intercept are both what point? 0, 0, yep. Because it crosses the x-axis at 0, 0, and it crosses the y-axis at 0, 0. For increasing and decreasing, remember that you read it from the left to the right. So the first question is, what is it doing? As we go left to right, is it increasing or decreasing? It's increasing. And it's increasing over its whole domain, so it's increasing from negative infinity to infinity. All right, end behavior. As x goes to infinity, y goes to what? Is it going up or down the y? All right, you're going to show me where's the y going. As x goes to infinity, thumbs up if the y is going up, thumbs down if the y is going down. Which way is the y going? I see a couple people voting. You could even go sideways. I have no idea. That's fine too. All right, thank you to people who voted. It is going up. So as x goes to infinity, the y is slowly going up. And then as x goes to negative infinity, the y is slowly going down. Okay. This doesn't have one of those weird things that the square root function had right here. Remember, this one had as x goes to 0, y goes to 0, because it didn't keep going in that direction. All right, so on your calculator, we're going to graph problem 2, and we're going to see what do these transformations do to the graph, okay? So let me open my calculator. I'm going to press the y equals button right there and clear out what's in there. And I'm going to type 3. I'm doing problem 2, so I'm going to type 3 and then the math button to get the cube root. And then x plus 1. And then the right arrow to get out of the cube root, and then the minus 2. Raise your hand if you'd like to see the those buttons again. Anybody want to see those buttons again? I have no votes, so if you want to see the buttons again, let me know. Very good, thank you. All right, so the first button I pressed was y equals, and then I cleared out everything in there. Then I pressed 3, and then for the cube root, I pressed the math button, and then choice 4 was cube root. X is right here next to alpha plus 1, and then I have to use the right arrow to get out of the cube root, and then minus 2. Now you could try pressing graph, but sometimes the window's messed up, so if you want to make sure you have a good window, press zoom and choose standard, which is 6. Notice that like mine looks like it has a little break in it. It actually doesn't have a break. The cube root function won't have a break in it. I don't know why it looks like that, but it does. And so you can actually see the inflection point is right where it thinks it has a break right here. So the inflection point is at -1, -2. So let's see how that compares to what's on our paper. Also, I'm going to sketch a little graph of this on my paper. So I'm going to make my inflection point at -1, -2. Even though there's no place for that. And I am going to make sure that I see that it goes through that point 0, 1. So I'm going to make mine do that too. And then like this. Because this is going to help me do the graph characteristics. All right. So this was my inflection point right here at -1, -2. I saw it on the graph, but you can also get it from your equation. So remember that this one happens opposite. The x plus or x minus is opposite. And then it's going to be the same as this. So my inflection point is the opposite of the +1, -1, and then the same as this one, -2. The transformations from the parent function, so remember this is my parent function right here, and then this is mine. My inflection point shifted from 0, 0 to -1, -2, so it shifted left 1 and it shifted down 2. And then there's one more thing that happened to the graph, and it involves this number 3 in front of the cube root. The number 3 in front of the cube root, what do you think that did to the graph? Talk to your neighbor for a moment. What do you think the number 3 in front of the cube root did to the graph? You get that right there. All right, I heard some of the groups discussing. Throw an idea out there. What could it have possibly done? The 3. You guys don't want to be wrong? Nobody has any idea, so it's okay. It's fine to be wrong. What could it have done to the graph? Dylan, what could it have done?
Like,
Even if you're wrong, I don't care. I want ideas. Say it again.
like stretched
It could have stretched it. Who agrees that that is within the realm of possibilities? Maybe the 3 could have stretched it. A couple people are agreeing. Maybe. Good. Did anybody have a different idea? All right. In this case, the 3 does stretch it. So that was definitely a good educated guess there. Our graph, notice how this one was kind of more compressed up here. You see it? And then our graph got taller in both directions. So it got vertically stretched, and it got vertically stretched by 3. Okay, vertically stretched by 3. So those are the 3 transformations. One from the +1, one from the -2, and then one from the ×3. Take a moment to try to fill in domain, range, intercepts, increasing and decreasing, and end behavior. What did you notice about the domain and range of this function versus the domain and range of the original cube root function? What's different about them? What's different about the domain and range of number 2 and the domain and range of the parent function? Morning. Nothing, right? There's nothing different because they both go all the way left and all the way right. Yeah, they both go all the way down, all the way up. And so every cube root function is going to have that same domain and range. Even if you reflect it, if I reflect this function, I'll just have a different side going down and a different side going up. So your cube root function will always have the same domain and range. That's easy. Square root, that's going to be trickier. All right, on the graph, we could see your y-intercepts. So your graph is here. You can see your y-intercept is crossing right here at 0, 1, but your x-intercept, that is not going to be as easy. So we'll have to figure out how to find our x-intercept. But our y-intercept is 0, 1. We're going to come back for the x-intercept. Increasing or decreasing this graph, is it increasing or decreasing? It's increasing. Now, if I had a reflection, if I had a negative in front of the graph and it reflected upside down, then it would be decreasing, but this one's increasing, and it's increasing over its whole domain. The whole thing is increasing, so it's still going to be increasing negative infinity to infinity. Because this graph was not reflected, it's going to have the same end behavior as the parent. As x goes to infinity, the y goes to infinity. As x goes to negative infinity, y goes to negative infinity. So a lot of the same stuff as the parent. All right, but we do have to find the x-intercept. And I don't have a lot of space for it, so I'm going to use like a little post-it note. If you have any scrap paper, you can also use scrap paper because we're going to have to do a little work to find the x-intercept. And this is where we're going to incorporate the last lesson. Okay. To find the x-intercept, you set your y equal to 0, because everywhere on the x-axis y is 0. The y, remember, is the f of x part. So what I'm solving is 0 for f of x equals 3 cube root x plus 1 minus 2. If you have scrap paper, you can do it on scrap paper. If you want to grab a marker, you can do it on your desk. But this is a review of last lesson, right? We have to solve this for x. So take a moment, please. Write this problem down somewhere, either with pencil or with marker, and solve this problem. Guys, we did this last class. You guys did all these on Delta Math. You told me you were pros at it. How do we get x by itself? First step.
Subtract or add 2.
Yeah, we have to get rid of the minus 2. Remember, you start at the end of PEMDAS, so we have to undo the subtraction or the addition first. Okay, so that will go there, and I get 2 equals 3 cube root x plus 1. Now I have to get rid of the times 3 with what? I'm going to divide by 3. So I'm going to divide by 3, and I get this fraction 2/3. If I did 2 divided by 3 on my calculator, it would say 0.666666666. And that's not what I want. I want 2/3 the fraction. Okay, so I have 2/3 is equal to the cube root of x plus 1. How do I get rid of cube root? Cube. So to get rid of cube root, you're going to cube. Those will cancel. 2 to the third is 8, and 3 to the third is 27. And then finally, I'll subtract 1. All right, those will cancel. And if you want to, you can use your calculator to do 8 over 27 minus 1, or if you know how to do it in your head, that's good too. I'm going to switch over to the calculator. So second quick gets you out of the graph. 8 over 27. Subtract the 1. And we don't want this. Hello, Yusuf. Then do math. Fraction. And I get negative 19 over 27. Okay, so my x-intercept is negative 19 over 27, comma 0. Get back to work here. You may work ahead. If you get as far as the very last problem, you can access the link to that in Schoology. But right now I'm doing this one, number 1. So if you haven't graphed it yet on your calculator, let's do it right now real quick. Press y equals, clear out what's in there. You need square root, which is above the x squared, so press second, square root, x. Use the right arrow to get out of that, and then minus 2, and your graph looks like this, okay? You can see that your graph starts down there at 0, negative 2. So you're going to do a little sketch. Okay, so your graph started here at 0, negative 2, and it went like that, right? So that start point, if you can read it from the graph, is 0, negative 2. If you have trouble reading that point from that, here's where you can find it on your calculator. So you're on this screen right here. We want to look at the table of values. So press second graph. Go ahead and do that unless you've already done that. Press second and then graph. You can see a table of values when you do that. Now you can scroll back in this table of values. You see how I have error? That's because those points are not defined. So the very first point that's defined is 0, negative 2. That's how I know that's my start point. Okay? So if I was having trouble seeing it on the graph, I could do second table and find that 0, negative 2 is my first point. And that's going to be helpful because that means my x's start at 0, so my domain goes from 0 all the way right to infinity. And my y 2, so my range is from negative 2 all the way to infinity. Okay, my y enters on the y-axis. Remember, this is the y-axis, and it happens to also be that same point, 0, negative. And then for my x-intercept, I need to see if that's going to be or if I'm going to have to solve for my x-intercept. I'm going to go back to my graph. And I can see it crosses right here at 4. If I wasn't sure, I could go back to the table. Notice that when x is 4, that is my x-intercept, 4, 0. Is this graph, as you read it left to right, it's increasing. So circle, and it's increasing the whole time. You always use for increasing and decreasing, so I'm using the numbers from domain. Increasing and decreasing always gets parentheses. This graph has an endpoint, and we already said the endpoint is at 0, -2. So I'm going to write the endpoint. And then we have to do the end as x goes to positive infinity. Is it going up or down? It's going down? Let's see. It goes to positive infinity. This y still is going up, positive infinity. Can't go to negative infinity because there's nothing over here on the side, so we just write goes to, and its very last point on the left side is 0 to 0. Y goes to -2. So notice the from your endpoint.